Welcome to class 11 chemistry practicals. Today we will just look at what is the chemistry practicals for class 11. So first and the foremost, let us know the marks differentiation of for chemistry. So now out of 100 marks, 70 marks is for theory and 30 marks is for practicals. Again, these 30 marks has been differentiated in three different ways. 10 marks is for one experiment and another 10 marks is for other experiment and 10 marks is for record and viva. Record and viva questions. So totally for record we have 6 marks and for viva we have 4 marks. In case of viva, there is a chance of asking 4 questions or 3 questions or only 2 questions. If 4 questions are asked, each question carries 1 mark. If 3 questions are asked, then 1 question carries 2 marks and remaining 2 questions carries 1 mark. And only 2 questions are asked means each question carries 2 marks. This is how marks has been differentiated for class 11 practicals. Like I told in the beginning, we have totally 20 marks for experiments. So what are the different experiments we will be having for class 11? So we have 2 different types of analysis. One is quantitative analysis, then other one is qualitative analysis. Qualitative analysis. So one experiment from quantitative analysis and another experiment from qualitative analysis. So we have only 2 experiments to perform in the lab, that especially for your final exam. So let us start with what do you mean by analysis? In a simple manner, analysis means identification. That's it. So it may be anything, but we are dealing with the chemistry. So hence we always identify the composition of the compound. Composition of the compound. So that is what analysis. But to do analysis, we have a systematic procedure. We have a systematic procedure. So that is why we always say that systematic analysis. Now, in case of analysis, we have 2 different types of analysis. One is called as quantitative analysis, then other one is called as qualitative analysis. Qualitative analysis. So in quantitative analysis, analysis will be done in terms of its quantity. In terms of its quantity, wherein qualitative analysis will be always done in terms of its quality. Again, in quantitative analysis, we have 2 different types. One is called as gravimetric analysis. Then other one is called as volumetric analysis. Volumetric analysis. So this about quantitative analysis we'll study in detail in later classes. Now let us just concentrate on qualitative analysis. So in a simple manner, I want to say about qualitative analysis is nothing but identification of chemical composition. It's nothing but what? Identification of chemical composition of a compound. That's nothing but qualitative analysis. So as we know that qualitative analysis is nothing but identification of composition of chemical substance. Now we know that chemical substance are nothing but it can be inorganic in nature or it can be organic in nature, which means either we are using inorganic substance or we are using organic substance. But for the syllabus, we don't have any organic substance, wherein we are having only inorganic substance. So, in short, inorganic substance will always called as salt. It's always called as what? Salt. But this particular salt means what now? Let us have a look at it first. Salt, it's nothing but a chemical compound made up of only one type of cation. Made up of only what? One type of cation and one type of anion. One type of anion. That's nothing but salt. But how this inorganic salt is produced? It is produced always by the neutralization of an acid with base. Acid with base. Now let's look at very simple example of neutralization reaction. Now let us take HCl, that's nothing but hydrogen chloride, when it is made to react with strong base, which is nothing but sodium hydroxide, which will always giving rise to the formation of a salt, that's nothing but sodium chloride. Then there is formation of water. So right now the compound what we have gotten, it's nothing but salt. Now here we observe two different types of ions. One is positively charged, another one is negatively charged. Sodium ion always carries positive charge and chloride ion always carries negative charge. So sodium ion, which is obtained by a base, so hence the ion will be always called as basic radical. It's always called as what? Basic radical. Similarly, Cl minus ion, which is obtained from an acid, so hence it's always called as acid radical. Acid what? Radical. So in a salt, suppose the ion is obtained from an acid, then it's always called as acid radical. If the ion is obtained from a base, then it's always called as basic radical. So, or else basic radical can also be called as cation, or acid radical can also be called as anion. Hence, the name of the experiment is always, we have a systematic procedure or a fixed procedure to do the analysis. So hence we say systematic. Then semi-micro, which is nothing but what? Semi-micro means during analysis we always take either 0.05 gram of the substance or 1 ml of the solution. So we will be using 0.05 gram of the substance or 1 ml of the solution. So that's why we call it as semi-micro. And type of the analysis we are using or we are taking is qualitative. Systematic, semi-micro, qualitative analysis of which type of compound we are using. Is it inorganic or organic? It's nothing but inorganic. So hence we say inorganic salt analysis. Inorganic salt analysis. So this is the actual name of the experiment. Now let us just look at the glasswares or glass apparatus which we are using to perform qualitative analysis. So we make use of test tubes, n number of test tubes. Why? Either we will be using salt or we will be using solution of this salt. So therefore we always consider test tube. This is how test tube looks. And then to place test tube, we use test tube rack. We use test tube rack, and then we will be using test tube holder. Why we will be using test tube holder? Whenever we are heating or boiling the reaction mixture, we always use test tube holder. So in a test tube holder, we place test tube and then we close the knob. So this is how test tube holder will be used. Then apart from this test tube rack and test tube holder, one more thing is also that to take inorganic substance, we use one more apparatus, nothing but spatula. Then next will be to use reagents, we use glass droppers. Then next, apart from that, we also use glass rod. Why we use glass rod? To perform flame test or to perform glass rod test. And then next one is watch glass. Why do we use watch glass? Because to perform or to prepare a paste for flame test, we will be using watch glass. Then last but not least, glass tube. Why it is used? Why? Because from the reagent bottles, to take the reagent, we'll always use glass tube. How to use glass tube? We have to place it in a bottle and then we have to close the mouth of the tube using forefinger and then we have to remove it. So now when you look at the glass tube, we'll be observing solution in it, and then after that in a test tube, to the test tube, we have to leave the solution by using the forefinger. This is how glass tubes will be used. So these are the main important apparatus. But apart from that, in chemistry lab, we have working table and also we have one shelf on working table and we will be placing certain important reagents on working table, and all these reagents which are placed on working table are commonly used, and there are certain reagents which are kept separately, like how we have placed acids and certain chemicals, those are all less commonly used. And also we will be having Bunsen burner in a lab. Why we have Bunsen burner? Because we will be heating or boiling the reaction mixture, and also we will perform some important dry test, and one example for dry test is flame test. We will be discussing it later in detail regarding flame test. Now let us just look at the important steps we have in inorganic salt analysis. So now in case of inorganic salt analysis, we have three important steps. So one is called as preliminary observation or preliminary analysis. Then next step is detection of acid radical. That's nothing but detection of anion of the salt. Then the third step is detection of basic radical, which is nothing but detection of cation. So these are the three steps we have in salt analysis. First and the foremost, why we have to perform preliminary analysis. Now, before starting with the preliminary analysis, I want to give an important information regarding salt analysis. Salt analysis will be always done by using two important properties. What are those? So we can do the analysis by following its physical properties and then by following its chemical properties. So physical properties are nothing but what? It's nothing but like we have mass, volume, melting point, color, odor, like that. So many physical properties we have for a chemical substance. Now let's go back to the first step of the salt analysis. That's nothing but preliminary analysis. So why do we need to do preliminary analysis for in case of inorganic salt analysis? First and the foremost, by looking at the color or state of the salt, we'll get to know, means there is a chance of guessing what type of anion or what type of cation we have. So that is the reason we'll always go with the preliminary analysis. So what are the 3 points we are checking in case of preliminary analysis? So firstly, we'll look at the state of the salt. Then next, we'll look at the color of the salt. Then next, we'll check the solubility of the salt. So these are the 3 aspects we will be concentrating in case of preliminary analysis. So what does this state means? We know that a compound can be in a solid state or liquid state or in a gaseous state. But right now we are dealing with inorganic salt. So obviously it will be in solid state. But in case of solid state, we have 2 different types. What is it? One is called as crystalline, or it can be amorphous, or it can be what? Amorphous. What is this crystalline and amorphous state of this salt? Crystalline means, now to do the state test, we always do one thing. We will take certain amount of salt on our hand and then we rub it. Suppose if we feel pricking sensation, then it's always crystalline salt. If suppose the salt is having very smooth texture, then it is always considered as an amorphous salt. So if crystalline salt means, easily we can say that one particular anion is absent in it. What is that anion? We'll look into it later. So if it is amorphous means, then only one type of anion is present in that salt. Again, while looking into the classification of the radicals, there I will be explaining which radical is crystalline and which radical is amorphous salt. Now, let us look into the color of this salt. So, color here, according to the syllabus, either we have white colored or colorless salt, and there is only one colored salt we have, and that colored salt representing cation, which is nothing but Mn2 plus ion, is nothing but what? Mn2 plus ion. So now the last one is we are checking the solubility of the salt. So in case of solubility, we use 2 different types of solvents. What are those 2 solvents? One will go with, firstly we'll go with water, and then we'll go with HCl, hydrogen chloride. So these are the 2 solvents we are using, but we will check whether the salt is soluble in cold condition or in hot condition. This is how we'll perform the solubility test. So according to the syllabus, all the salts are soluble in cold condition except one salt, that is manganese ion salt. Now, before going with the acid radical detection and basic radical detection, let us just classify all the radicals, acid radicals and basic radicals, into several groups. As I told, now we are differentiating radicals into 2 different types, acid radicals and basic radicals. So what do you mean by acid radical and basic radical? In the beginning itself we had observed the ions which are obtained from the acids in neutralization reaction is known as acid radicals, and the ions which are obtained from the base in neutralization reaction is nothing but basic radicals. Now these acid radicals are differentiated into 3 groups. So first group, second group and third group. What are the radicals coming under each group? So in case of first group, we have different types of radical. So one is called as carbonate radical, then other one is called as sulfide radical, then next is sulfite radical, that's nothing but SO3 2 minus, then the another one is called as NO2 minus, nothing but nitride ion. Then the last one is acetate ion. So these are the 5 important radicals, acid radicals we have under first group. But out of these 5, we have only one radical for first year. That's nothing but class 11. So similarly in second group, we have different types. So first one is chloride radical. Next is bromide radical, then next is iodide, and then next one is nitrate ion. So these are the 4 important radicals we have, but for our syllabus, except iodide ion, we have other 3 ions. Now in the last group, we have 3 different types. One is called as borate ion, that's nothing but PO3 3 minus. Then next one is sulfate ion, SO4 2 minus. Then the another one is called as phosphate ion, PO4 3 minus, ma'am. PO4 3 minus. Phosphate ion, PO4 3 minus. So again here in case of third group, only one ion we have for syllabus, that's nothing but sulfate ion. That's it. This is how we have differentiated into several groups. Why we have differentiated into 3 groups? Whatever the radicals, acid radicals we observe under first group will always give similar observation with respect to one particular reagent. And that particular reagent is always dilute mineral acid. Is always what? Dilute mineral acid. In the lab, means a dilute mineral acid, it can be dilute HCl or it can be dilute sulfuric acid. But we always use dilute HCl as a reagent for first group. So hence, the group reagent of first group is always dilute HCl. Is always dilute HCl. Similarly, second group acid radicals also give similar observation with concentrated acids, and that is why the reagent is considered as a group reagent. So the group reagent for second group is concentrated H2SO4. But in case of third group, none of the radicals give similar observation with any one of these reagents. So that's why the third group is always called or considered as independent group. It's always considered as independent group. So therefore, we'll always check each radical. So it's a particular test itself confirming the radical also. This is how we differentiate acid radicals into 3 groups. Similarly, we also differentiate basic radicals into 7 groups, starting from 0 group and it goes on up to 6 group. Goes on up to 6 group. So 0 group, first group, second group, third group and fourth group, fifth group and sixth. So this is how we have 7 different groups. What are the radicals coming under each group? In 0 group, we have ammonium ion. In first group, we have lead ion, Pb2 plus ion and silver ion, Ag plus ion. In second group, we have copper ion, Cu2 plus ion and arsenic ion. Okay, arsenic ion. And in third group, we have aluminium ion, Al3 plus ion and cobalt ions. So man CO3 plus cobalt है. 2 plus third group ತಾನೆ cobalt. Hey ma'am, fourth third group ಅಲ್ಲಿ aluminum ಬಿಟ್ಟು ಯಾವುದು ಹೇಳಿ? ಅದು ಎಲ್ಲೋ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲೇ ಇದೆ ನೋಡಿ, ಸೆಕೆಂಡ್ ಕ್ವಾಲಿಟೇಟಿವ್ ಅನಾಲಿಸಿಸ್ ಅಲ್ಲಿ. ಕಾಪರ್ ಆರ್ಸೆನಿಕ್ ತಾನೆ ಸೆಕೆಂಡ್ ಗ್ರೂಪ್, ಆರ್ಸೆನಿಕ್. ಅದೇ ಗೊತ್ತಾಯ್ತು, Fe3+ ion ಮ್ಯಾಮ್. Aluminium and Fe3+ ion. Then in fourth group we have Zn2+ ion and Mn2+ ion. Then in fifth group we have 3 radicals. One is barium ion, then strontium ion, then calcium ion. Then what? Calcium ion. And in the last group we have another 3 radicals. One is Mg2+ ion, then potassium ion, then sodium ion, Na+ ion. But out of these radicals we have only few radicals for the syllabus. So one is 0 group radical, that's nothing but ammonium ion, and in third group we have aluminium ion, and in fourth group we have zinc ion and manganese ion, and in fifth group we have barium ion and calcium ion, and in sixth group we have only one ion, that's nothing but Mg2+ ion. But we don't have any radicals of first group and second group for the syllabus. So only we have the radicals of 0 group, third group, fourth group, fifth group as well as sixth group. That's it. So now let us just look at the end. One more thing I want to mention, like how we had observed the group reagents in case of acid radical. Similarly, we also have the group reagents in case of basic radical also. So group reagent, that's nothing but for 0 group ion, group reagent is NaOH solution. Now in case of third group reagent is ammonium hydroxide and ammonium chloride. Apart from these two, one more reagent is also there for fourth group, that's nothing but H2S. And for fifth group, again we have these two reagents, nothing but ammonium hydroxide and ammonium chloride are common from the third group to sixth group. Apart from these two, we have other reagents for fourth, fifth and sixth group. That the reagent, other reagent only I am writing it. So for fourth group, we have hydrogen sulfide. For fifth group, we have ammonium carbonate. And for the sixth group, we have phosphate, disodium hydrogen phosphate. Disodium hydrogen phosphate. So these are the group reagents. Why? In case of third group, we always observe hydroxide precipitates. We always observe what? Hydroxide precipitates. Like I already mentioned previously, all these radicals are grouped. Only why? Because all these radicals are showing similar observation with the reagents. So that is the reason we will be using the reagents as its group reagents. Now in case of third group, aluminium ion and ferric ion will always give rise to formation of a precipitate, and that's nothing but hydroxides. Similarly, we have fourth group radicals, that's nothing but zinc and manganese. It will give rise to the precipitates, sulfide precipitates. So that's why we use hydrogen sulfide. And in case of fifth group, we have precipitates are nothing but carbonates. They are nothing but carbonates. So that's why we use ammonium carbonate. And last but not least, sodium disodium hydrogen phosphate. When we use it, we get the precipitate as phosphate. Phosphate precipitate, we get it. So that's the reason disodium hydrogen phosphate, we use it as group reagent. Then what about the first group and the second group? I mentioned only 0 group, third group, fourth group, fifth and sixth group. I didn't mention first and the second group. Though it is not there in a syllabus, for our information, will just let us know the group reagent and what type of precipitates we get here. So, now in the case of first group, we always use dilute HCl as a group reagent, and for second group, we use dilute HCl, and along with that, we also use hydrogen sulfide. So, lead and iron, lead and silver, it will be always gives rise to the formation of chlorides. And in case of second group, the precipitates, they are nothing but sulfides. They are nothing but sulfides. So, this is how basic radicals are differentiated into 7 groups. So, we just learned the differentiation of acid radical and basic radical into several groups. Now, let us move on to the steps of the salt analysis. Previously, we just got to know, we have completed with the preliminary analysis. Now, we'll move on to acid radical detection. So, in case of acid radical detection, again, we have 3 steps. What is that 3 steps? Firstly, we have to detect the group. Why do we need to detect the group? Because we are not aware of which radical is present in the salt. So, that's the reason to reduce our job. So, first and the foremost, we need to detect the group, and then once we detect the group, then we have to identify the radical. We have to identify the radical. Once the radical is identified, then finally we will confirm the radical by performing confirmatory test. So, these are the 3 steps involved in acid radical detection. These 3 same steps which are also involved in basic radical detection. So, first is group detection. In case of basic radical, we have 7 different groups and so many ions are present in each group. So, that's the reason to reduce our work, first we'll identify the group. So, once we identify the group, then we will identify the radical. Then finally, we will confirm the radical. We'll confirm the radical by performing confirmatory test. So, this is how we have to follow each step during inorganic salt analysis. So, group detection, radical identification and confirmation of radical. So, now let us look at the acid radical detection and basic radical detection in detail. First, let us start with the acid radical detection. So, as we know, in case of acid radicals, we have 3 different types of group. So, for the first group, we have what? We have group reagent, and that group reagent is nothing but dilute mineral acid, which is dilute HCl. So, now in case of one more important point I want to mention here, in the case of acid radicals, directly we will use salt. Sometimes we will use salt and sometimes we will use solution of the salt. We will use what? Solution of the salt. Why? In case of, suppose, direct salt we are using. Why? Because there is liberation of certain characteristic gases which we can observe very easily. So, that time we use direct salt. In case of, suppose, during the analysis we observe precipitate formation. What do you mean by precipitate? It's precipitate means what? It's nothing but solid which is formed in solution due to a chemical reaction. So that's what we call it as precipitate. In case in certain tests we observe precipitates, for that test we use solution of salt, but in certain tests we observe liberation of characteristic gases. For such type of test we use direct salt. So now in the case of acid radical detections, for first group and the second group, we always take salt itself. That's it. We don't take solution of the salt. So we will take salt. To that salt, we will add dilute HCl. So once we add dilute HCl, if suppose first group acid radicals are present, then we observe effervescence. This is the major or important observation for first group acid radical. What do you mean by effervescence? It's nothing but bubbles. We observe bubbles. This bubbles means we all know that the bubbles in aerated rings, whenever we are shaking aerated rings and open the cap, we observe that bubbles which are burping out. That similar look we observe in the test tube after adding dilute HCl to the salt if suppose first group acid radicals are present in it. If we don't observe effervescence, then we say that there is no effervescence means then what? It's nothing but first group is absent. First group acid radical is absent. Suppose if effervescence are observed, then we can say that first group acid radicals are present. It may be carbonate or it may be sulfide, nitrite or acetate. But according to our syllabus, we have only one type of acid radical, that is carbonate radical. And after effervescence, we also observe evolution of colorless gas. We also observe what? Evolution of colorless gas. That's for first group. Now, as I told in the beginning, if there is no observed effervescence, we always say that what? We say that first group acid radicals are absent. Then we'll move on to second group acid radical detection. So what is the group reagent for second group acid radical detection? Concentrated sulfuric acid. So once we add concentrated sulfuric acid, then we observe first vigorous reaction. You observe vigorous reaction. Apart from that, other than vigorous reaction, we also observe evolution of certain gases. Evolution of what? Certain gases. Suppose if chloride radical is present in the salt, then the gas which is liberated is hydrogen chloride. If suppose bromide is present in the salt, then we observe bromine gas. If we have iodide ion in the salt, then we observe iodine gas. Then if we have nitrate ion, then we observe nitrogen dioxide gas. But all these gases, they have their own characteristic color. If chloride radical is present, then hydrogen chloride gas which is liberated is always colorless. If bromide radical is present in the salt, then the bromine gas color which is liberated is always reddish brown color. If iodide ion is present in the salt, then iodine gas which is liberated is always violet color. If nitrate ion is present in the salt, then nitrogen dioxide gas which is produced is always reddish brown or only brown color? So just by looking at the colors of the gas, we can identify the radicals. We can identify the radicals. It may be chloride, bromide, iodide or nitrate. But one important point we have to remember here. What is it? In case of chloride, bromide and iodide, means very easily we can observe the liberation of characteristic colored gas. But in the case of nitrate ion, we don't observe the liberation of gas very easily. Though there is liberation of nitrogen dioxide gas, but when we observe in the test tube, we are not able to see it. To observe that, what we are doing is, we will be adding a catalyst to catalyze the reaction. So what is it? What is the catalyst we are using? Either we can use copper turning or we can use just paper pellet. So what is this paper pellet means? It's very simple one. That's nothing but a small paper ball we are using, which is catalyzing the reaction. So after adding the catalyst, easily we can observe the reddish brown color gas for nitrate ion. Suppose if we are not observing anything, that means there is no vigorous reaction and there is no evolution of gas, then second group acid radicals are absent. It is absent. Then finally, we'll move on to third group. For first group and second group we have done. Suppose if there is no reaction, then we say that second group are absent. Now, what are the radicals of third group? We have three radicals: borate, sulfate and phosphate. But for our syllabus, only one radical we have, that's nothing but sulfate. So third group, it's an independent group. Why we call independent group? Because the radicals of third group doesn't give similar observation with the reagents like dilute acids, mineral acids or concentrated sulfuric acid. So that's the reason third group is considered as an independent group. So directly we'll perform the test for borate or phosphate or sulfate. But here we'll check only sulfate ion. That's it. So this is how we detect the acid radical. So with that, we have completed with the acid radical detection. Now the third step of salt analysis is basic radical detection. So now we will just look at the basic radical detection in detail. Once we done with preliminary analysis and acid radical detection, then we will be moving on for basic radical detection. So what are the three steps we have for basic radical detection? So in case of basic radical detection, first we identify the group, which is nothing but group detection using group reagent. Once we identify the group, then we identify the radical. Then after radical identification, then we confirm radical by performing confirmatory test. So now let's start with each group of the basic radical. So first group is zero group. So what is the ion present in zero group? Ammonium ion. So except zero group, for other group basic radicals, we always use salt solution. So instead of saying or instead of calling salt solution, we call it as original solution. Why we call it as original solution? Because the solution of the salt can be prepared either by using water or dilute HCl. So in short, we say that solution of salt is completely depending upon the solubility of the salt. So that's why we call it as original solution, not just as salt solution. So now let's move on to the basic radical detection. That's nothing but zero group basic radical detection. I told already, for zero group we use salt. Directly we are using salt. Why? Because while performing the experiment we observe there is gas liberation. We observe gas liberation. So that's the reason we use salt. And the reagent which we are using is sodium hydroxide solution. So once we take sodium hydroxide solution to salt, after boiling the solution, if we observe ammonia gas, and how we observe there is liberation of ammonia gas, whenever we smell the reaction mixture, it always have a pungent smell. It always have a pungent smell. So that's why we say that ammonium ion is present in this salt. Suppose if we don't have, or if we are not observing any pungent smell, then zero group basic radical ammonium ion is absent. So once we know that zero group ion is absent, then the radicals may be a first group, second group, third group, fourth and so on. So what is the group? After once we completed ammonium ion detection, next we will prepare salt solution. It is completely depending upon what? It's completely depending upon the solubility of the salt. Solubility of the salt. So now, once original solution is prepared, now the solution will be taken in different test tubes. To the original solution, if we add dilute HCl, after adding dilute HCl, suppose we observe any precipitate. If we observe what? Any precipitate, then first group basic radicals are present. First group basic radicals are what? Present. But suppose after adding dilute HCl, then we don't observe any precipitate, then first group basic radicals are absent. Now to the same solution, which means in a test tube we have already taken original solution and we also have added dilute HCl to the same solution. If we add hydrogen sulfide, if we add what? Hydrogen sulfide, if we observe any precipitate, if we observe what? Any precipitate, then second group basic radicals are present. Second group basic radicals are present. But instead of that, if we don't observe any precipitate, then second group basic radicals are absent. But as we know already, there is no first group and there is no second group for the syllabus. So that's why once we done with the preparation of original solution, directly we can start checking for the third group basic radical. Third group basic radical. So what apart from original solution, what's the other reagent we are using for third group basic radical? One is ammonium chloride crystals and ammonium hydroxide solution. We'll add ammonium hydroxide solution. So here we can observe precipitate. We'll be observing what? Precipitate once again. So that precipitate will be always white colored gelatinous precipitate. White color gelatinous precipitate. What is this Gelatinous precipitate means it is very similar. Precipitate is very similar to the gel. So you all familiar with the hair gels what we are using. So that is the texture of the precipitate we observe in the test tube. So that's why we say white colored gelatinous precipitate, which indicates aluminium ion is present in the salt. Once it's done, then we'll perform confirmatory test. We'll perform what? Confirmatory test to confirm the radical. So while performing confirmatory test for aluminium ion, we will take original solution and then to that we will add NaOH solution. So after adding NaOH solution, firstly we will get white color gelatinous precipitate. White color gelatinous precipitate. Then next thing, once we get white colored gelatinous precipitate, then we add excess of NaOH solution. So once we add excess of NaOH solution, then we shake the test tube. So once we shake the test tube, suppose the precipitate which is obtained is found to be always soluble. It's always found to be soluble. So once the precipitate is soluble, then next what we are doing to the clear solution. Whatever the clear solution is obtained previously, to the clear solution, we will add ammonium chloride crystals. So after adding ammonium chloride crystals, gelatinous white precipitate reappears. Previously it was soluble. So after adding ammonium chloride to the clear solution, it will reappear. So this is the confirmatory test for aluminium radical. Suppose if we don't observe gelatinous precipitate, then it says what? Then third group basic radical, that's nothing but aluminium ion is absent. So next what we have to do, we'll go for fourth group basic radical detection. So what we know first, we identified, first we were checking whether zero group basic radical is present. So over there is no liberation, there was no liberation of gas, means then it was indicating zero group basic radical was absent. Then next we prepare salt solution depending upon the solubility of the salt. Then next, once we prepare salt solution, then we check whether first and the second group basic radicals were present or not. But as we know for our syllabus, there is no first and the second group basic radicals. So that's why we directly go on to third group. So in third group what we did? We used original solution. To that we added ammonium chloride crystals and ammonium hydroxide solution. If we were observing white colored gelatinous precipitate, then we were stopping there itself. We were confirming the radical by performing the confirmatory test. But right now we observe there was no precipitate, so that's why we had gone to fourth group detection. So again for fourth group, which means in previous group we had already taken, in a test tube we had taken original solution, then ammonium chloride crystals and ammonium hydroxide solution were taken already. To that we will add hydrogen sulfide. We will add what? Hydrogen sulfide. Here in fourth group we have two different colored precipitate. So either it can be white color precipitate or buff colored precipitate. Buff color means what? Very similar to the paint of this color or wall. Paint of this wall, that's nothing but buff color. If suppose white colored precipitate is obtained, then the radical is Zn2 plus ion. Instead of that, if we get buff colored precipitate, then it's nothing but manganese ion. It's nothing but manganese ion. But instead of white or buff colored precipitate, then there is no precipitate in the solution, which indicates fourth group basic radicals are absent. Fourth group basic radicals are absent. So now what we have to do? If we don't observe any precipitate, then we'll move on to fifth group detection. Fifth group detection. But before going into fifth group detection, let us just look at the confirmatory test for zinc and manganese. For zinc and manganese, for both the radicals, apart from original solution, we use sodium hydroxide as another reagent. If zinc is present after adding ammonium hydroxide solution to the original solution, then we observe white color precipitate. We observe white color precipitate. Then once we get white color precipitate, after adding excess of NaOH solution, then the precipitate will be always soluble. It will be always soluble. Other than using NaOH solution, we also use another reagent for zinc confirmation, which is nothing but potassium ferrocyanide solution. Potassium ferrocyanide solution. So here one can be original solution with NaOH solution, and the another test is original solution with potassium ferrocyanide solution. So after adding potassium ferrocyanide solution, then we get bluish white colored precipitate. We get bluish white colored precipitate. Now we'll look at the confirmatory test for manganese ion. As I told in the beginning, same reagent we will use. That's nothing but NaOH solution. So after adding NaOH solution to the original solution, then for manganese ion, firstly we'll observe white color precipitate. We'll observe white color precipitate. Then after some time, the precipitate will change to different color. The color of the precipitate will be changing to brown color. Initially it is white color, then once it is exposed to air, then it will change to brown color. So that's the confirmatory test for manganese ion. This confirmatory test will be performed only when we observe precipitate after adding hydrogen sulfide to original solution, ammonium chloride and ammonium hydroxide mixture. Suppose we don't observe anything in the test tube, then we say that fourth group basic radicals are absent. Then we directly move on to fifth group basic radical detection. Once we know that fourth group basic radicals are absent, then we'll go for fifth group basic radical detection. So to original solution, we have to add ammonium chloride crystals, and then we'll add ammonium hydroxide solution, and then we will add ammonium carbonate solution. Ammonium carbonate solution. And if we have fifth group basic radicals, we observe white color precipitate. We observe white color precipitate, and precipitate, they are nothing but carbonates. They are nothing but carbonates. Suppose we don't observe any white color precipitate, then it indicates fifth group basic radicals are absent. Fifth group basic radicals are absent. Now let's look at, if we get white color precipitate, then it may be barium ion, or it may be strontium ion, or it may be calcium ion. We have to follow the same order. So first we should check barium, then we should check strontium, then we should check for calcium. So what is the test for barium ion? To the original solution, we add potassium chromate solution. We add potassium chromate solution, and the observation for barium ion is yellow colored precipitate is obtained. If barium ion is present in the salt, then we get yellow colored precipitate. But if we don't observe any precipitate after adding potassium chromate to the original solution, then it indicates barium ion is absent. That's why we'll check whether strontium ion is present or not. So, to strontium, we'll add ammonium sulfate solution to original solution. If we observe white color precipitate, then strontium ion may be present. Suppose if we don't observe white color precipitate, then strontium ion is absent in the solution. So finally, we'll check whether calcium ion is present or not in the salt. So for that, we'll take original solution in a test tube. Then to that, we will add ammonium oxalate solution. After adding ammonium oxalate solution, suppose we observe white color precipitate, then we say that calcium ion is present. It is present. If we don't observe any precipitate, then calcium ion is absent. So there is no question of absence of calcium ion if we get white color precipitate during group detection test. No barium and no strontium means obviously it is calcium ion itself. So once we done with the radical identification test, then we'll perform confirmatory test. For these three radicals, confirmatory test is not called or wet test. It's not considered as wet test, wherein it will be always called as dry test. Before going into what is dry test, or before going into the confirmatory test of these three radicals of fifth group, let us know what is this wet test and dry test. In the case of wet test, we always use solution of the salt. In case of dry test, we don't use any solution, wherein we take directly salt. So that's the reason we say dry test and wet test. So here, let's go back to the confirmatory test for fifth group basic radical. So for fifth group basic radical, confirmatory test is always a flame test. It is always what? Flame test. It is an best example of dry test. It's an example of dry test. Why we perform flame test? Only for fifth group basic radicals. So we know that barium ion, strontium ion and calcium ion, it belongs to which group in the periodic table? It belongs to second group, nothing but alkaline earth metal. So second group is nothing but alkaline earth metals, and we had studied that alkaline, in case of alkali and alkaline earth metal, there is one characteristic property, that is nothing but the compound or its respective salt will always impart characteristic color. It always impart what? Characteristic color to the flame. Why? Because during that particular test, there is liberation of volatile chlorides. There is liberation of volatile chlorides. So that's the reason we observe some characteristic colors whenever we perform flame test. So what are the characteristic colors for these three fifth group radicals? For barium, it is always apple green color. Wherein for strontium, it is always crimson red color. And for calcium, it is always brick red color. The procedure. What is the procedure for flame test? We always prepare a paste using concentrated hydrochloric acid. Using concentrated hydrogen chloride, and once the paste is prepared, the paste will be held in a flame. It is always held in a flame, and once, suppose if you observe apple green color, then it is barium, or crimson red color, then it is strontium. Then if it is brick red color, then it is calcium. This is the flame test. Now we'll perform the flame test so that we'll get to know what kind of color we have or we observe for all these three radicals. So now we are performing flame test. The procedure I already told, which is nothing but we have prepared paste of this salt using concentrated HCl, and paste should be or will be held in to the flame, and in case of flame we have to hold the paste to non-luminous flame. To what? Non-luminous flame. So about Bunsen burner we'll study in detail in the later classes. So we are observing apple green color to the flame. So which means it's indicating barium ion. So we have observed how apple green color is obtained. Now we'll look into the strontium radical. What is the flame color for strontium radical? I already mentioned it's nothing but crimson red color. How crimson red color is observed? Now we have prepared the paste using concentrated HCl, and the paste is held in a flame. Beautiful crimson red color we are observing, which is indicating strontium ion. Similarly, we'll do for calcium ion also. So the color of the flame for calcium ion is brick red color. So paste of the salt is held in a flame. We'll observe brick red color. When the paste is held, we are observing brick red color. So this is how we perform flame test, and we also observe different flame colors for fifth group basic radicals. So we observe the different flame colors of the fifth group basic radical. But the flame test is performed only when we observe white color precipitate in the group detection test. Instead of observing white color precipitate, if we don't observe any precipitate, then it indicates fifth group basic radicals are absent, which means now the radical may be present in sixth group. may be magnesium or potassium or sodium. So now let us look at the sixth group, basic radical detection. For sixth group, we have to take original solution, and to that we will add ammonium chloride crystals, and we'll add ammonium hydroxide solution. To that we'll add another reagent, that is disodium hydrogen phosphate. So finally we'll observe white color precipitate. We'll observe white color precipitate, which indicates 6 group basic radical, and it may be magnesium. It may be magnesium ion. Whatever the test we had performed to detect the presence of 6 group, it is nothing but confirmatory test for magnesium ion. There is no radical identification. So once we get white color precipitate after adding disodium hydrogen phosphate, we finally say that magnesium is present and confirmed. So in short or briefly, I say that first we'll check whether 0 group is present or not. If there is no evolution of gas, then we'll check first group basic radical is present or not. If there is no precipitate after adding group reagent, then it means we have to go for second group. Again, after adding group reagent, there is no precipitate, means then we'll move on to third group. Similarly, we'll go for the other groups also. So there is no radicals from 0 to 5th group, means finally we'll conclude that basic radical which is belonging to 6th group itself. So group detection test, radical identification and confirmatory test for magnesium ion is same. That's it. There is no special confirmatory test for magnesium ion. So with that, we have done with the basic radical detection also. So first we have done with the preliminary analysis, and then we have gone for acid radical detection, then we have gone for basic radical detection. Once we done with each and everything, then finally we have to report the given salt. What does this report means? In result, we will be writing what is the acid radical we had identified and what is the basic radical we had identified. So once we know acid radical and basic radical, then easily we will be writing name of the salt. We'll write name of the salt. Then after writing name of the salt, in square bracket we will be writing formula of the salt. We will be writing formula of the salt. This is how we will be reporting the inorganic salt. Now let us take an example so that we'll get a clear picture how to report the salt. For example, now we are doing the test for sodium chloride salt. Now sodium ion is cation and chloride ion is anion. Acid radical is nothing but anion, basic radical is nothing but cation. So for sodium chloride salt, acid radical is Cl minus ion and basic radical is Na plus ion. And name of the salt will be written as sodium chloride. And the formula will be written as NaCl. This is how we will report the given inorganic salt once we done with the entire analysis. So we studied how qualitative analysis will be conducted in lab for a particular inorganic salt. Now for the syllabus, how many salts are there? Totally we have seven different salts. So what is it? So first salt is ammonium chloride. Second salt is ammonium bromide. Then next is aluminium sulfate. Then next is manganese sulfate. Then next is barium chloride. Then next is calcium carbonate. And finally, we have magnesium sulfate. So these are the 7 salts we have for class 11. Apart from these 7, we also have 6 different salts, but we will study in class 12.